If a car didn't have a differential, this is what could happen when it turns, like in the example on the left. Why does this occur? When a car turns, the outer wheel must travel a longer distance than the inner wheel. As a result, the inner wheel must rotate slower than the outer wheel without a differential. To compensate for the speed difference between the two wheels, the inner wheel will slip, leading to loss of traction control or even a rollover. So how does a differential work? Imagine two wheels that can rotate independently. If we add a spoke to each wheel on their respective axles, the left and right wheels can rotate separately. But what if we want both wheels to rotate together? The solution is simple. We add a crossbar in the middle, which allows both wheels to rotate simultaneously. But how do we secure the crossbar? It's easy. We add a connecting rod to the axle and attach it to the spokes holding the crossbar in place. However, in this setup, both wheels rotate at the same speed, which means they will still slip when turning. So what can we do? We can place a bearing in the middle of the crossbar to allow it to rotate freely. Now, when the car turns, the faster moving right wheel will cause the crossbar to rotate, letting both wheels maintain their individual speeds. But there's still an issue. When the difference in speed between the wheels becomes too large, the system might still fail. How do we fix this? To solve the problem, we can add more crossbars to ensure power is consistently transferred to the wheels, even if one wheel isn't rotating. However, this method still isn't ideal because it causes power loss and interruption. So to improve efficiency, we increase the number of crossbars, making the system denser. In reality, the differential in a car works based on this principle, but instead of crossbars, gears are used and the system is much more refined. Let's take a closer look at how the modern system works. First, the engine's power is transmitted through a small gear at the end of the drive shaft to a ring gear. The ring gear is connected to a planetary gear, which not only revolves around the ring gear, but also rotates on its own when external force is applied. The planetary gear meshes with two side gears, which are connected to the two-wheel axles. The engine's power flows from the drive shaft's small gear to the ring gear, then to the planetary gear, and finally to the side gears, which then power the wheels for better power transfer. There's actually a second planetary gear opposite the first one. Now let's visualize how the differential works. When the car drives straight, only the small gear connected to the drive shaft and the ring gear rotate, while the other gears remain stationary. But when the car turns left, all the gears begin to rotate, and you'll see that the gear on the left axle rotates slower than the gear on the right axle. The opposite happens when the car turns right. All the gears rotate, and the left axle gear turns faster than the right axle gear. This is how the differential allows your car to turn smoothly and even when the wheels are rotating at different speeds.